Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the ability to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can before the end of today's webinar. And also at the end of today's webinar, we are going to be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our two lucky winners. All right, with that, we will go ahead and kick off today's webinar, which is how to run Kubernetes securely and efficiently. Our speakers today are Joe Pelletier, who is VP of Product at Fairwinds, and Robert Brennan, who is Director of Open Source at Fairwinds. Gentlemen, thank you so much for joining me today.
Thank you. We're really excited today to walk through today's topic. I just want to give everyone a quick preview of the agenda. So we're going to just discuss a little bit around why organizations choose Kubernetes, some of the key challenges, as well as the technical implications for security and efficiency. And then we're going to go through different ways configuration validation solutions can help. So we know that containers today are changing how software is developed. And really at its core, containers package the dependencies so apps can run in any environment, whether it's the cloud or an on-premise data center. And what that means is the software packaging is just shifting left. Developers are getting more involved, and developers are taking responsibility for containerizing their applications, or they may even be responsible for parts of the Kubernetes configuration. We also know that container adoption is growing quickly, and some Gartner estimates say that in just a few years, 70% of enterprises will be running 2 or more containerized apps, and that's up from 20% last year. And from our own observation and research at Fairwinds, we're noticing that Kubernetes is quickly entering the mainstream. In many cases, this is happening through development teams who are starting new projects, and they're looking for that agility. They are tasked with getting their product out to market quickly, and they want the agility of getting infrastructure up and running, whether it's in the cloud or in their data center. And chances are, if you're using containers today in your company, you are either on the path of using Kubernetes or already there. We're seeing increasingly that this is two technologies that go hand in hand. Now, one of the business benefits of choosing containers or Kubernetes is really around time to market. Time to market and speed is really where a lot of companies are finding that value. And there's a few different areas that we want to highlight here. And this is a great graphic that we've seen circle around. I think we found this one through an AWS presentation. But really the first one is around the ability to commit code and deploy it to production very quickly. The essence of meeting customers and getting customers value quickly is around how can you take an idea and deliver it all the way to production. And with containers, you can do that quickly. You can package up your application, ship it to whatever environment you have set up, and we're seeing organizations realize an order of magnitude improvement there. The other one is the ability to spin up IT infrastructure resources. And the cloud obviously makes that easy. But to be able to do that at scale and align with your software development practices is really where containers and Kubernetes technology can be very powerful. But like with any new technology, there's challenges. And the CNCF recently did a survey late last year around the different challenges organizations are facing with container technology. And they boiled it down to a few different categories, but the top 3 are really around the cultural shift of moving to containers and Kubernetes, and that cultural shift and how it affects DevOps teams and development teams. The second is really around security. So security is typically always in a catch-up position when new technologies emerge. and we're starting to see this becoming more and more of a area of investment for organizations. And the third is complexity. And by complexity, we mean not only just technical complexity, because Kubernetes does introduce a lot of complexity, but also a lot of flexibility, but also the organizational complexity that can emerge as well. So we'll talk about these three as we go through today's presentations and how to think about it. So first, let's take a look at that cultural shift that happens when organizations adopt containers. As a result of that, you still have the same key stakeholders, which is development, DevOps teams, and security teams. But when it comes to development, they're going to be taking on some more ownership here of the IT infrastructure in the form of containers and deployment configuration. We talked about how development teams might be containerizing their applications and doing that so that they can get them to run in the production environment. And we also have started seeing some development teams taking responsibility for parts of the Kubernetes deployment configuration. So if you build a container, you are likely going to have to deploy it to a Kubernetes environment, and there's still an additional amount of configuration that's involved there. Now, we also know that development teams, they're really paid to write code and build features and ship roadmap. And so a lot of development teams, are still focused on those key activities. So when it comes to containers and Kubernetes deployments, they tend to want to just do enough to get the application out. And we'll talk about the implications of that in just a minute. Now, the DevOps team, they're also tasked with being able to build core infrastructure that the development teams can deploy to. And when you move to containers and Kubernetes, you have to select and make decisions around configuration. You have to keep security, efficiency, and reliability in mind. And a lot of DevOps teams also go out and research a variety of software add-ons to Kubernetes, such as DNS, certificate management, and ingress, in order to ensure that they have a strong base infrastructure to run the applications on. And that's where a lot of responsibility comes in from the DevOps side to make sure that base layer is set up, configured to run efficiently and reliably, so that those development teams can do what they need to get the apps running. And finally, we all know that security cares about all the steps in the process. They care about how are the containers configured, how are the deployments configured, and is my core infrastructure up to the compliance internal requirements that security teams have. But this is also an area where different risks can emerge. And from our perspective, we have seen risks emerge both in the security context as well as in the resource and efficiency context. So when it comes to container technology, known vulnerabilities or CVEs or untrusted images are really key considerations that development teams need to have when they're building those containers. We don't want organizations to introduce new risk, and being able to inspect those containers for those types of issues are really important. The second area is really around configuration. We talked about how development and DevOps teams may have some overlap in responsibility here. And when it comes to the deployment configuration, this is an area where, again, development teams may do just enough to get their app deployed. They may end up over permissioning containers by having them run as root or exposing the file system to read and write access. They may also ignore some different configurations around resource efficiency, such as what are the CPU and memory requests and limits that should be set to run those applications efficiently in production. And finally, if you're on the DevOps side, you're also needing to maintain the set of add-ons that you have chosen to run a core Kubernetes infrastructure. And that means paying attention to versions and software patches and making sure that the configurations of those add-ons are also done in a secure, efficient, reliable way. So these are just some examples of the types of challenges. And later in this presentation, I'll have my colleague Robert walk through a couple of these examples. Now, let's take a look at the complexity angle. Complexity was another area where the CNCF survey found a great deal of pain and problems for enterprises adopting containers and Kube. And when we look at complexity, we really see this as an organizational challenge in addition to a technical challenge. For example, if I'm a developer working on containers or Kubernetes technology, I want to understand, how can I quickly get what I need done in my configuration so I can go back to writing code. And a lot of times the developer may not know exactly how much CPU and memory they need to provision for their app. So these are some areas where they can spend a lot of time and effort getting this information into the configuration. The second might be from the SRE. And the SRE, who's responsible for keeping and monitoring the applications in production, they may be looking for certain configurations that could be missed as part of this process. Finally, we know that the security team will want to understand the security posture of the containers and Kubernetes infrastructure, and that the VPE, they're always thinking about the balance between security and speed and efficiency and reliability. They want that reliable infrastructure so that they can support the next wave of customer growth, and they have to consider all the other stakeholders and business requirements in order to do that. So a lot of interest from a lot of parties, and that can create a complex environment to work through. Now, the third finding from the CNCF survey was around security, and there are definitely different considerations for security along the process here. When it comes to containers, we talked about the CVEs and image pull policies that need to be considered, but we're also seeing that the deployment configuration for Kubernetes itself is an emerging area of risk. It's an area of risk for security, but also an area of risk for efficiency from what we have done and found as research here at Fairwinds. And those efficiency risks can be around, have I set the right CPU and memory limits? And have I ensured that the application has the right health checks enabled so that it can run reliably? The third technical area is the actual cluster itself. Security plays a role there, as well as the ongoing usage and monitoring of usage of applications so that you can set those CPU and memory settings correctly. Now, what I'll transition over to Robert, my colleague here, to talk a little bit more about the security and efficiency aspects of Kubernetes at a technical level.
Thanks, Joe. So yeah, as Joe alluded to, at the workload layer, there are really two halves to the problem. On the one half, you have the container itself, which consists of the base image as well as any software that you layer on top of it. And those are both locations where known vulnerabilities might exist. And then the other half is the Kubernetes configuration, which basically wraps around that container and tells Kubernetes how to deal with it, how to scale it up and down, how much memory and CPU it needs, how to tell if it's healthy, and what sorts of permissions it needs. So on the container side, the most important thing to be sure of is that you're not running any known vulnerabilities inside of your containers. And again, the two halves to check here are the base image itself, which may contain vulnerabilities, as well as any software that you're manually installing on top of that base image. There are a lot of great open source tools as well as commercial tools that can do this type of scanning for you. They basically maintain a database of known vulnerabilities and can check a running container against that database. One thing we see a lot of organizations do that's really good is to integrate container scanning into their CI/CD process. This makes sure that at the time of the pull request, there aren't any vulnerabilities inside that container image. The issue with this, though, is that if that CI/CD process passes, the container gets checked in, it finds its way into your cluster, and then the next day a new vulnerability is announced, you no longer have eyes on whether or not that vulnerability is in your cluster. So it's important to continuously scan any images that are running in your cluster in case new vulnerabilities are announced after the CI/CD process. So moving over to the workload configuration half of things, there's a lot of security considerations there. Often the easiest way to get things working in Kubernetes, especially when you're first making your transition, is to do things in an insecure way. So we often see developers granting their deployments additional security permissions that aren't necessarily something that their app needs in order to do its job. And so it's important to routinely audit your security configuration around workloads to make sure that these security configurations are as tight as they possibly can be. And this is important because if an attacker does manage to find a hole in your application and gain access to the container itself, if you have a tightly pared down security configuration, they're going to be stuck inside that container and they're not going to be able to spread throughout the cluster. But if that container is, say, running as root on the host node, it has access to the host network, it has certain capabilities, that attacker can gain access to the underlying node and then find access to other secrets and basically be able to spread throughout your cluster and find all sorts of things that they're not supposed to have access to. Another thing at the deployment level is health probes. This is basically how Kubernetes checks to see if your application is alive and ready to start serving traffic. This is an optional piece of configuration, and so it's often neglected. It's very important that Kubernetes has this information in order to be able to scale workloads up and down appropriately in order to detect if a workload has gotten into a bad state and is no longer healthy, and to be able to roll out new deployments in a way that doesn't cause downtime. If you don't set these liveness and readiness probes, then you can experience a lot of issues, both with scaling and with new rollouts. And in addition, so like you can see here in the configuration that this developer set, there's no liveness probe, and the readiness probe is also overly simplistic. It's just checking if this index.html file is being served. It's really important that the readiness probe actually check that your application is ready to serve traffic, make sure it's connected to the database, make sure that any underlying microservices have been connected to. It's important to make these checks as thorough as possible. And then another big part of workload configuration is setting resource requests and limits. Again, this is a piece of configuration that is optional, but strongly recommended. Without resource requests and limits set, it's easy for workloads to accidentally end up consuming a lot more resources than they were intended to consume. Say if there was a memory leak introduced or an infinite loop was triggered somehow. This is often a difficult thing for developers to know ahead of time how much in production, how much memory and CPU their application is going to need. So often we see developers either neglecting to set these entirely or setting them to something that's way beyond what they actually need. You can see in this particular example, the developer has set the workload to use 4 CPUs and 20 gigabytes of memory, which is almost certainly overkill. And this can lead to cost overruns, if the developer has over allocated resources to their workload, or B, if they haven't set any resources and the workload ends up consuming more than it should. It can also lead to a lot of instability where one workload begins to gobble up all the resources available on a particular node, and other workloads aren't able to get the resources that they need to scale up. So just to review, we looked at 2 security issues, one on the container side of things and one on the deployment configuration side. We also looked at a reliability issue with health probes missing, as well as an efficiency issue and a cost issue in terms of resources being set appropriately on workloads. And now Joe is going to come back and talk a little bit about validation configuration and how you can make sure that you're proactively checking for these types of issues so that they don't actually become a problem in production.
Great. Thanks a lot, Robert. I think those are really helpful examples. So, when you do face these challenges with your containers and Kubernetes configuration, fortunately, there are options to ensure that you are configuring Kubernetes in a secure and efficient way. And there's an emerging category called Kubernetes configuration validation that's allowing DevOps teams to maintain consistent configurations for their containers, deployments, and cluster infrastructure. And with these types of tools, there's a variety of ways you can leverage a configuration validation solution. And there's different avenues to go down. We'll share that in just a little bit. But it gives users that visibility as well as the recommendations that they need to make the changes. And we think that this is going to become a really important part, especially for organizations that are early in their Kube journey. They may have embraced containers, they're now deploying them to Kubernetes, and they start getting those questions around, am I doing things the right way? Do I have the security profile and posture that I need to ensure that my customer trust? Am I running my workloads as efficiently as possible? These are the types of questions that configuration validation can help. So we want to be able to share with you some steps for implementing configuration validation in your process today. The first step is really around data. So a lot of the examples that Robert shared are things that can actually be detected today, whether you're early in the development process or even running workloads already in production. But getting that data and understanding what the risks are from a security and efficiency perspective is the most important part to start with. And fortunately, there's a lot of open source tools out in the Kubernetes ecosystem that enable this. We all know that Kubernetes is an ecosystem powered by open source, and increasingly some of the best of breed tools in this space are de facto open source as well. Now, once you get that data, it's important to not just run the tool once and get the data. It's important to be able to get the data and analyze it, organize it, and then prioritize it so that you can understand what the next steps are. And with this data, we all know that getting everything into one place and then being able to understand what the most important thing is can be a very time-intensive process. Anyone who's analyzed security findings or production information knows that there's a lot of data that just needs to be crunched. And a great configuration validation solution is going to do a lot of this heavy lifting for you. They're also going to provide you with a way to run these tools continuously so you can stay on top of what's changing, especially in the Kubernetes context where things are generally ephemeral. The third is, once you have some of this information, you want to be able to understand what is the problem and who does it affect and be able to sign it out to an owner. Making sure that someone owns the issue and that the issue can be integrated with the tools that they use, whether it's a monitoring tool, a chat system, or a ticketing system. Those are the types of integrations that you want to look for so that you can get the information into the hands of the folks who need it the most. And finally, there's a number of different ways to address these challenges. So understanding what's the best practice for making this change. Do I have to make this change now, or should I think about this as a long-term improvement? Those are the types of advice and guidance and remediation expertise that you'll need to collect along the way. So given that process, we wanted to share a few different paths forward. The first path that we've seen organizations take is building their own tools. And this can be a very important step, especially if you have nuanced or specific requirements that you need to be able to validate against. Fortunately, though, as I mentioned, the Kubernetes ecosystem is powered by a lot of great open source. And so the open source option is another great path to go down. We're talking about containers and deployments and cluster security. So there's actually a variety of tools that map into those different technical areas. And the third option is using a purpose-built platform, a platform designed for Kubernetes configuration validation that allows you to automate this and be able to integrate it into the systems that you use every day. So let's walk through the pros and cons of each option. When you go down the path of building your own tools, the advantages of this is you're going to get something obviously fully customized to your needs, and it's going to be something that will be very specific to your environment and will allow you to validate certain configurations each and every time you deploy. And for some organizations, you do need that. Take this approach. It will also give your engineers a great opportunity to go out and build and learn Kubernetes by building the tools they need to do their job. But as we know, and just especially in today's environment, time and money and cost is of the essence. And so this could potentially be a big effort that you also have to maintain over time. And unless it's an absolute necessity to build your own configuration validation, a lot of organizations may not actually invest in this route for the time and cost investment that's required. The second option is using open source tools, and this is a really good approach. The advantage is there's a lot of open source available in the market today, and there's increasingly number of open source tools available through GitHub and other online sources. And we'll see that even if you go and browse GitHub, you'll see that there's a list of dozens of open source tools available. Last time I checked, I think I found a list of 40 plus security tools for Kubernetes. So there's a lot of different options out there. But the downside of using open source is it can also carry a lot of expense over time. Each tool might cover a very specific use case. It's also hard to stitch together and run and operationalize those tools at scale, especially if you're in a multi-cluster type of environment or a multi-cloud environment and need to have continuous visibility. It's possible, it's just a lot of heavy lifting. The third approach is using a purpose-built platform. So going down the path of looking for a configuration validation platform that covers your containers, deployments, and cluster. And the advantages of this approach is that one platform can really cover a variety of use cases. We're talking about security, efficiency, and in some cases reliability as being different angles to look at to assess your overall Kubernetes health. And some of these purpose-built solutions may include expertise, especially cloud native or Kubernetes expertise to help you with the remediation and addressing those issues. The downside, of course, is that these are typically commercial in nature. They cost money. They may also have proprietary tooling or proprietary commercial components, and so that's where cost becomes a factor and may need to be budgeted in order to get this planned out as part of your program. If you do decide, though, to go down the path of looking for a purpose-built solution, we wanted to make sure you were aware of some different things to look for. So some of the characteristics of a purpose-built configuration validation platform, the first and foremost thing is it's going to provide you with a prioritization of findings from multiple open source tools, typically in a single pane of glass approach. So that single pane of glass is going to be a unified platform that includes all of your clusters across all your clouds and helping you look at the most important problems across all of that cloud native landscape. The second piece is really around the out-of-the-box integrations. So it's important to get this information into the hands of the different folks who need it. We talked earlier how developers, security, and DevOps engineers are all different stakeholders here. They all use different systems, so you want to be able to make sure the data can get into the systems that they use so that they can get the visibility they need. The third area is going to be ensuring that you're covering a robust technical landscape. So you want to make sure you're addressing container risk, but you're also inspecting the Kubernetes deployment, which is emerging as an important area of investigation, as well as auditing your cluster for both those security and resource efficiency gains. And finally, you want a solution that has a great roadmap that evolves to the cloud native ecosystem. You want a solution that also provides you with expertise and remediation advice, because ultimately you want to be able to prevent problems from occurring. And so getting really powerful remediation advice is going to be helpful in terms of accelerating your time to fix. A couple other areas to consider when you go down the path of configuration validation is where are you going to implement it in your development process. Now, a lot of solutions might by default integrate themselves into your running cluster, which is helpful for understanding and answering the question, what's my current security posture, or what's my current health of my Kubernetes infrastructure? And those tools are going to come back with a bunch of recommendations that will help you prioritize what should you do next. But to prevent issues from occurring in the future, it's important to look at solutions that can also integrate earlier into the pipeline. A lot of organizations may already be embracing container scanning, and that's fantastic. These are great solutions to integrate into your CI process. But increasingly, a lot of organizations are also looking into the deployment validation around their Kubernetes deployment configs, and they're trying to make sure that they're avoiding a lot of the challenges that Robert shared earlier in his slides. So these are some considerations for the natural integration points for a solution like this. Finally, business benefits. In order to go down this path, you have to have a business ROI so that your executive teams and your decision makers can understand what are they going to get out of this investment. And naturally, improving security is one area that configuration validation can help you with. When it comes to improving security, you're going to gain kind of immediate visibility into the health of your Kubernetes infrastructure from a security perspective so that you can prioritize those improvements. But increasingly, we're seeing a lot of organizations who embrace config validation going down and seeing cost and time savings. So a lot of engineering teams might be trying to build their own tools or trying to do this today. And in order to get the ROI you're looking for from those resources, you want to be able to invest in a proper configuration validation strategy to really make it more efficient to deploy and save your engineering team's time. And of course, Fairwinds has created a guide for a lot of organizations to use to help them manage their configurations for security, efficiency, and reliability. So if you're interested in learning more about just different ways to address these challenges, we have this guide available for free on our website. Just go to fairwinds.com and click on the resources section. We have also recently built a product in this space that helps you have that turnkey purpose-built configuration validation solution that you can kind of get ready, you can use immediately. And that's available at fairwinds.com/insights, and there's a trial available for free. So with that said, I'm going to turn it back over to the folks at devops.com and see if we have any questions.
All right, great. There's plenty of time for questions. We have almost a half an hour, so go ahead and send in your questions via the GoToWebinar control panel, and we'll go ahead and get started here. Let's see, our first question. When does it make sense for organizations to adopt configuration validation solutions?
That's a great question. Robert, you want me to take that? So I think I'll go ahead and just take that one. So I think with configuration validation, this is a great solution for organizations who are moving down the path of embracing Kubernetes, maybe for the first time. They are setting up their staging and production environments. They are starting to deploy their containers, and they've gone past the point of, okay, it feels like we know how to get things running in Kube, which is great. But at that point, there's a lot of questions around, am I doing things the right way? And that's where configuration validation can really help. So I look at this as a great solution for folks who are just starting their Kubernetes journey. Now, companies and organizations who are already been using Kubernetes for the past few years, they may also want to be able to evaluate what has changed about Kubernetes over the past few years and what are some of the new best practices that should be considered. And so configuration validation can also be powerful for them to get another check-in on whether or not their containers and their deployments and their cluster are set up securely and efficiently. So I think it applies to a broad part of the market, but really those organizations that are just getting up and running, this can be a very powerful way to put in a solution and get value really quickly.
Thanks, Joe. Yeah, just to expand a little bit on that, particularly for the first half, you mentioned folks that are early on in their Kubernetes journey. I think implementing container validation at that phase in your journey really helps to establish good habits around writing these configurations. It's easy to fall into bad habits quickly if you don't have a configuration validation solution in place, letting you know what you might be doing wrong early in the process. And it's really hard to change those habits once they've been established.
Excellent. Okay, great. Next question. Does configuration validation run using static analysis, or does it use sampling on a live Kubernetes system? In other words, could I build it into my CD process?
That's a great question. It's really a combination of both. We see about half of it gets implemented as part of the CI/CD process because it can run statically on just the YAML files that are being checked in or the Docker files that are being checked in. There are things though, like checking resource efficiency, where you really do need live metrics on a production deployment in order to see what real life resource usage looks like. And there are some things that need to be checked in terms of live networking and stuff like that. So some things we've seen is that folks will run, in addition to running validation as part of CI/CD, they'll run it in a staging cluster, especially if they're creating ephemeral deployments in that staging cluster or in some development cluster. There are some validation tools that can run against an ephemeral release before the PR gets merged, as well as running validation on the running production cluster. Like I said before, if a Docker image makes it past CI/CD, there were no vulnerabilities at that time, there can still be a vulnerability announced days or weeks later, and you want to be able to catch that inside your production cluster.
Oh, excuse me. Okay. Next question. Can this fit into a security deep scan or penetration testing?
Yeah, I can start with that question. So I think that this is a great way to get started from a deep scan or penetration testing perspective. From my experience working with folks in that role, they're looking to collect a lot of data about the environment to understand what are some of the risks that an automated solution like a configuration validation platform could find before they go in and expose other types of issues that only really a human could potentially expose. So I think it's a great way to start a penetration test if you're focusing on the Kubernetes infrastructure by going down this path. That's my 2 cents. I'll turn over to Robert from a technical perspective if you have anything else to add there.
Yeah, I totally agree. I think if somebody had access to a cluster, a part of a cluster running this validation, as a pen tester to basically explore where other possibilities for privilege escalation, et cetera, might exist. I think a configuration validation solution would be very useful for a pen tester.
Excellent. Okay. Plenty of time for questions, guys. So if you do have one, go ahead and use your GoToWebinar control panel and submit it, and we'll just keep right on going as long as we've got questions. Our next one here, any suggested tools to secure at a network policy level, either to understand what is getting blocked or what is getting out that we need to block?
That's a great question. We've actually been looking a lot at network policy as somewhere for us to go. There isn't a tool out there that we have been entirely satisfied with, so there's none that I would personally recommend. I think it's a rapidly evolving part of the market though, and I think my hope is that something, especially it's something open source, might pop up in the coming months. Joe, I don't know if you have any eyes on products in that or open source tools in that space.
No, I would have to agree with your point of view there, Robert. I do think though, when you think about configuration validation, network policy is definitely a component to that, right? And so while there might not be a great solution today, I think when you think about the category and you think about a solution over time, that will likely eventually become part of an overall suite of tools that go out and inspect, clusters and network configurations.
All right, great. Next question here. Considering we use Kubernetes for microservices at scale, does configuration validation handle sidecar proxies that can handle security automation such as secrets management or certificate management, particularly for service-to-service calls?
So generally speaking, without knowing too much about this particular setup, generally speaking, configuration validation is going to focus on first-class Kubernetes objects. It's going to play most nicely with Kubernetes native ways of doing things. So if this sidecar proxy is using native Kubernetes types in order to do its job, then I would say yes, it will. If it's using, a bespoke solution, a commercial solution, something that is proprietary, then it's going to be a little bit harder to plug into a validation solution.
Excellent. Okay. Let's see our next question here. For connections between pods, is it practical to use secure connections rather than just HTTP? And how is this typically configured? And is that configuration subject to validation?
Yeah, so it's definitely practical today to use secure traffic between pods, and it's definitely recommended. I don't know of any configuration validation solution, either open source or commercial, that specifically checks for that. But it is definitely something that you would want to check for, and that certain compliance standards would require. So I imagine there's something out there, but I don't know the name of a validation solution that would check for that.
All righty then. Okay, let's see. Our next question, can you recommend a tool for managing role-based access control in Kubernetes clusters?
Yeah, role-based access control is a big, hairy topic that we didn't get to in this presentation, mainly because I think it could deserve its own presentation. There are a couple tools that I think I could recommend. One is called Audit to RBAC, which is a very cool tool, open source, which looks at your audit logs to see basically what service accounts are accessing what types of resources, and then it recommends a very pared down principal of least privilege RBAC profile for that service account. So that's a great way to really make sure that your RBAC profiles are pared down to precisely what each of these roles really does need access to. Another one I'll recommend is RBAC Manager, which is one of our projects. RBAC Manager, again, open source project. It simplifies the configuration of RBAC. RBAC, one of the things that's complicated about it is there are two different CRDs that need to be, really three different CRDs that need to be, I guess they're not CRDs, but three different object types that need to be coordinated with one another. And what RBAC Manager does is it simplifies this down into a single CRD, so that it's a single YAML file where you can get the same kind of fine-grained access control, but with a much simpler and easier to reason about interface.
Excellent. All right, guys, there's still time for questions. So if you do have one, go ahead and put it in. Next question, if I use Istio with Kubernetes, are there tools to validate the Istio configuration?
I don't know of any that validate Istio in particular, but given that Istio is increasingly becoming a widely adopted standard, I would not be surprised to see one pop up. There are certainly tools to validate things like ingress objects and things like that. So to the degree that Istio uses native Kubernetes objects, you can validate those sorts of things. But there is a lot of Istio configuration that is very specific to Istio. So short answer, no, I don't know of anything that validates Istio, but I would expect something, if Istio continues on the route that it is, I would expect that it would start getting its own tooling around validation.
Yeah, and I have to agree with Robert. I think eventually over time it becomes in scope for configuration validation. I think the tooling is still somewhat emerging. I think we're also noticing that while Service Mesh and Istio are increasing in terms of adoption, it's still a relatively smaller part of the market of folks who are running and using Kube today. But I totally agree. I think over time that this becomes a more important piece of a configuration validation solution.
Excellent. All right. So many great questions that have come in. Our next one here, can this fit into a SOC monitoring system like Splunk ES, for example?
That's a great question. ultimately, the configuration validation solutions that we have seen on the market do have a great emphasis on integrating with systems. You know, the types of systems, including SIMs and Splunk, are definitely things that are in scope for that. You know, there's a lot of data that can come out of inspecting Kubernetes infrastructure for security and resource efficiency gains. And so having that into a system that's like a SIM that security teams might want to monitor and sort through definitely makes a lot of sense. So I would anticipate that as an increasing integration that you'll find in the future.
All right, great. I think we have, okay, here we go. Next question, what is the difference between configuration validation and chaos engineering?
That's a good question. I'm going to let Robert start with that one.
Sure. Yeah. So I would say configuration validation is a very proactive approach. It really uses it checks for very specific things in your configuration to see if there's something that you should change or should have eyes on. Chaos engineering is really is more of a catch-all. It's rather than looking for specific things, the idea is to sort of randomly take down parts of your infrastructure and see how resilient your infrastructure is to failure. So I would say configuration validation, if I could use a metaphor, configuration validation is kind of like unit testing, where you're checking for very specific things to make sure that they don't break. Whereas chaos engineering is a little bit more like a regression test, making sure that everything's working end to end, that everything's robust to failure. Hopefully that answers the question.
Excellent. Okay, still time for questions, guys. So if you have one, it's not too late. Go ahead and use your GoToWebinar control panel. And let's see, the next question we have is, what sort of configuration validation can be done at the cluster level?
Good question. So there's two good open source tools that come to mind about cluster level configuration. One is kubebench, which checks against the sys benchmark. This is basically a benchmark that I believe the CNCF provides for just making sure that you're doing things in the recommended way. And another one is kubehunter, which actively hunts through the cluster, checking mainly for networking vulnerabilities to make sure that things are tightened down. I think these the cluster level is a very big, wide open problem, much more so than workload validation. There are a lot of things that can be checked. A lot of organizations will customize their cluster level validation in ways that are hard to check, but it's an important thing to be sure of, because a small issue there ends up affecting every workload running in the cluster. So I think it's important to run tools like kubebench and kubehunter to make sure that things are pared down at the cluster level.
All right. Great. Next question. Is the configuration validation done at the source control or the cluster level?
So I would say both. It really, it's great to catch things before they make it, through the pull request and get checked in. It's great to catch things ahead of time like that at the source level. But it's very important to also run things at the cluster level, because really for two reasons. One, for if a vulnerability gets announced after the fact, after the pull request gets merged, you want to be able to catch that at the cluster level. And two, because not every it's possible to get things into a cluster without going through source control first. Folks are using kubectl to interact with the cluster. An attacker could, potentially get something into your cluster without having to go through your CI/CD process. So it's important to check not just what's being checked into the infrastructure repository, but to check the configuration that's actually made it into the cluster.
Excellent. Okay. Well, those are all the questions that we have so far from the audience. I'm going to leave the queue open for a minute or two and let folks get in any final questions that they might have. But while we're waiting, I thought maybe we could go ahead and do our drawing for the two $50 Amazon gift cards. So without further ado, we'll go ahead and do that. Let's see. So our first winner today is Dan G. Congratulations, Dan. And our second winner today is Jason M. Congratulations, Jason. We'll follow up with both of you offline by email to get your gift card over to you, so please check your inbox. And it looks like we did just get one more question in, so I'll go ahead and throw that out to you guys. How about using solutions like OpenShift?
Yeah, I can go ahead and take that. I think when it comes to solutions like OpenShift, I think they're great at being able to provide a management control plane for Kubernetes. They cover a lot more than just configuration validation. I think they're helping you with actually configuring and running Kubernetes workloads and the core Kubernetes infrastructure. Frankly, I think when it comes to solutions like OpenShift, or even if you're using a cloud managed service like GKE or EKS, for example, it's still important to have a configuration validation platform that allows you to make sure that the things that are being changed and made through those platforms are also aligned with best practices from a security perspective or resource efficiency perspective. We see a lot of our customers here at Fairwinds using, configuration validation tools in addition to the managed Kubernetes services or even OpenShift in their own environment. So I think they're very complementary, but it hopefully gives you a little bit more context of like where would that fit with something like OpenShift.
Okay. All right. Great. We did have two more questions come in, so if you guys are up for it, I'll go ahead and ask them. The first one is, if I use FluentD with Kubernetes for logging, are there tools to validate the FluentD configuration?
Yeah, so I think this is very similar to the Istio question, where we have, this is an add-on that's being installed on top of Kubernetes that's becoming increasingly popular. I think what we've seen is that, we didn't see configuration validation pop up for Kubernetes until Kubernetes became, the de facto way to, do cloud computing. Once Kubernetes, became widely adopted, that's when people started picking up on configuration validation. Right now, there are, I would say FluentD is getting there. It's getting to a point where it's popular enough that I would suspect that configuration validation is going to pop up for FluentD, but it's still not quite at the level of adoption that, say, Kubernetes itself is. So not quite, but I think we'll get there.
All right, great. And looks to be, let's see, another question. Is it possible to put config validation as pre-hook into, I can never pronounce this correctly, is it kubectl? How do you pronounce that?
There are 100 ways to pronounce that word. Everybody has their own opinion.
Okay. All right.
I say kubectl. Some people say kubectl.
Okay.
I hear kubectl. But this is a great question.
Right.
We actually have a project, an open source project called Polaris that does this. So Polaris does deployment validation. It'll validate really any workload configuration, from deployments to stateful sets to replica sets to just bare pods. And we do have a way of running Polaris as what we call a validating webhook. And so what this is it's a controller that runs inside the cluster, and it listens for anytime somebody tries to create a new deployment, tries to create a new pod, tries to create a new stateful set, and it will check that against a preset list of checks. And if one of those checks fails, or it's been configured to fail, then Polaris will reject that workload and not allow somebody to actually put it into the cluster. So this is a great way to make sure, absolutely sure that workloads that are doing things that are very insecure or that violate your organization's policies don't end up making it into your cluster.
All right. Okay, last question, then we're going to go ahead and close out the question and answer period. Is there any open source tool that can perform image vulnerability scanning at the cluster level?
Great question. Yeah. So the big open source scanning tool that we recommend is Trivy. Trivy really runs on a single image at a time. It is not immediately configured to run inside of a running cluster or to run on all the images inside of a cluster, but you could do, there's a bit of heavy lifting involved to basically, you have to grab all the images that are currently in the cluster, run Trivy on each of them. This is it's I would say aggregating all those results and then reporting them back to the user is the kind of thing that is probably out of scope for an open source project and something that you would find inside one of those purpose-built solutions that Joe talked about. This is really a question of like operationalization rather than core functionality.
All right. All right, guys. Well, as I said, we are 5 minutes to the top of the hour, and we've done, I think, almost a full half-hour question and answer period. So I think Joe and Robert are probably really tired. So we're going to go ahead and close out the question and answer period now. But I do want to thank everybody who did submit questions. There were so many good ones there. So thanks so much, guys. I really do appreciate it. I also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you. Joe, Robert, thank you so much for a great presentation. Lots of really good stuff.
Thank you.
Thanks so much. This has been fun.
Okay. All right, great. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.